All right, everyone, thanks for being here for Passive House Accelerator Construction Tech. We're really excited that you've joined us. And we're super excited to have Connor Malloy here to present about the Student Wall Assembly Competition. So lots to look forward to tonight. The Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the Passive House movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're happy you are here with us tonight. Thanks.
A little late, just rolled in is Zach's intro, but I just wanted to say I'm Kevin Brennan from New York City. I'm very proud and honored to be on the show tonight because we have an amazing show for you to highlight some amazing work that a bunch of kids around the U.S. compiled, and building science is reaching the masses. And it's exciting to know that what I learned as a young 21-year-old is now getting down to the level of 16, 17, 18, 20-year-olds. And it's the critical mass that we need to get people to build better is an earlier understanding. A lot of times I look at building a little bit like athletics, and how we inspire others is through a little bit of competition, a little bit of coaching, and a little bit of motivation. You know, with the Olympics coming up, I somehow kind of relate back to the fact that the wall assembly competition was like the Olympics of kind of our nerdness, and it was a great honor to see two New York City kids win the competition. So I can't wait to hear more about it, share the information, and Connor's done an amazing job of getting us off the ground, and love to see what's happening next year and everyone's thoughts on it. So thanks, guys.
That's a true story. I'm with Kevin. I absolutely can't wait to see what Connor's going to share with everybody, and then I can't wait to see what everybody wants to know right back. You're going to see basically a total work of art tonight in the art of education. This is the sharing of how to share, and you're going to get links. You're going to meet kids. You're going to see really amazing competition entries, and you're going to want to do this where you are too. So buckle up. And if you want to ask questions of Connor, please put a Q in front of your question in the chat. Make sure your chat is open. And without that, I'll pass it over to Sean.
Hello, everyone. So I'm in Vancouver. I'm in the middle of the heat wave. We're actually just coming out of the heat dome. My office is 31 degrees, as Maya aware. So this glistening face is not so much of coming out of a shower, but of hardworking sweat. And if I can make it through this show without sweating enough, I look forward to it. So if I fall off, it's because I've had some heat exhaustion. I'm looking forward to hearing Connor's story because I love the education and the educators that we have in the industry. We need more of them. And the fact that he worked with Travis to take on this effort and is working on creating a great program within the George Brown community college is pretty fascinating. So just so you know too, we've got lots tonight. Connor is going to do his thing. And then in the overtime, we're going to get some of the students on to talk about their stories and get the real nut and bolts of how late they spent on the night before to get us their presentation and all the little details of what they had to do to pull this through to be able to compete. And one of those actually won. So looking forward to it. Mark, over to you.
Let me try that with the mute off. Thank you, Kevin, Shannon, and Sean and Zach. So in the world of building science, I came across the BS and Beer show and got to know the folks that put that on, and Travis turned me on to Connor Malloy and picked up the phone and an hour and a half conversation happened. Y'all know I don't talk that much, so I got to listen quite a bit and learn about the incredible endeavor that he was taking on that we're going to hear about tonight. So the wallassembly.com happened first with a group of professionals. And in the second year, it was taken on by Connor, and somehow through divine help, we have the wallassembly.com domain that wasn't being used yet. So that got taken on and built up by Connor. And I'll say, when it comes to design thinking, innovative, sustainable building practices, and a contagious enthusiasm to share new ideas, that person is Connor. He is an incredible person that really is in the right spot. So being at George Brown College and being there for the students has opened up a tremendous opportunity. We're thrilled to have you on tonight. So Connor, take it away, brother.
Wonderful. Thanks, Mark. It's a pleasure to be here. I'm so fortunate to find this community to share ideas, talk a bit about what we teach at the college, but really, celebrate student work. That's why I left the building industry and pursued teaching full time, to really help push ideas, not just build 3 houses a year, but help 200 people go and build 3 houses a year. So that's kind of what I want to share tonight. I'm a big show me, don't tell me person. So let me pull up my slides now and we'll jump into this. So what we're going to talk about tonight is about the Wall Assembly Sweet 16, which we ran this year as a student edition. And thanks for having us on the Passive Accelerator. We'll talk a bit about how we founded the competition, about the student work, and how you can get involved for next year. So just quickly, just to tell you what we're going to talk about is, I want to tell you a bit about what we teach at a skilled trade school and what architectural schools are teaching about building science. So you have a good insight to where education is right now. We'll then get into kind of how we founded the competition, what the impetus was to get involvement going during the pandemic. We'll kind of jump into actually looking at the submissions that students entered in the competition. So we have a lot of those students here. So when we're discussing their work, feel free to add comments, and those students can get back to you and actually answer some questions about their assemblies. In the last hour, we're going to do a Q&A, not with me, but also with the students to talk about their work, their ideas, and their experience. And the big thing I want to highlight tonight too is how, like myself, I didn't know my college taught my program 5 years ago, even though I was a builder in the city, building high performance homes. So how we can think about getting involved in our own community, in our own schools, and helping to support students and support those faculty who are teaching those kind of classes. So that's what I want to talk about tonight. So I want to start off by asking Mark, what do you think skilled trade schools are teaching right now about building science? Just want to read the room on what we think is being taught.
I question that all the time. So my true answer is, I do not know if skilled trade tools are teaching about building science. So my guess is they're teaching based on the materials they have access to for the controls and the sequencing of what they're putting on, but it's probably based on what they have access to.
Right. That's you're hitting close to home. And let's think about Shannon. Let's think about design schools. Let's flip to then architectural schools and design schools. What do we think design schools and architecture schools are teaching right now about building science?
Such a great question. I'm going to give the Accelerator Harvard answer. It depends, right? It depends where you are. Is your school technical? Is your school theoretical? And even down to who's your instructor and what experience do they have? What did they learn? Are they still working off their old textbooks? Or are they actually using the internet and what's going on around the globe?
So those responses are pretty accurate, but does it fill you full of confidence that we can hit all of our goals? it's hard, right? I think that's why we all need to think about how we participate. I bet you we all have really up-to-date details, assemblies, and case studies that we can help advance this learning. So let me finish with Sean. This is hard to distill, but what should schools be teaching right now to achieve goals we have about pushing passive principles and achieving climate action?
Well, they need to just start implementing any type of building science discussions. I know at BCIT in the carpentry school, they get about 4 hours over the course of their 4-year apprentice when they're there. And if they fall asleep or if they had a good night before and it didn't show up, they're not getting the building science. So we need to be able to add it in and work with the unions to ensure that it's implemented.
Love it. Perfect. So we're going to dive into all of that right now and think about how we can, help support schools and think about how we can make some change and help out. So who I am, my background really is in renovation and building. I spent 20 years kind of growing up in the business, running residential job sites. I got really focused on, I got angry actually with the fact that most design 20 years ago was focused on luxury and materials, opulent spaces, adding onto homes. And I really questioned what that meant. So I started to produce sustainable architecture and think about green building. And that really advanced me to work for high performance builders. And I was only able to meet with a few clients a year and help them achieve their goals. Although those are great projects, it really felt that I could do a bit more by moving into a teaching space and helping students that are joining us tonight some of those principles so they can meet 3 clients a year and really impact more people and make a bigger impact. So I've been teaching full-time as a professor in the building and renovation department at George Brown College for the past 3 years. I'm also a certified passive house tradesperson, but my background really is not in building for teaching. It's really in design principles and that how we communicate and how we think. So my background's in interior design and then did a master's in interdisciplinary design strategy. All that means is I'm pretty good at thinking about ways and tools to have different groups of people, think subtrades, engineers, architects, actually work together on complex problems, which is what we're all talking about right now. So that is me. I'm also known as Bike Dad around the neighborhood. I am quite tall. I stand out. Yeah, I'm pretty big, but I've got a weird bike. So if you see me around Toronto, I'm not, the prof. I'm Bike Dad. I'm also known as that 3D guy. So during the pandemic, we've been really focused on. So we got a student like William right now, who I can see is in his basement because you can see his ceiling, of getting our students out of their house while they've been locked up inside. So we've really networked this past year to how do you teach building science and get people into job sites if you can't physically go to a site. So we've been working with local tradespeople and actually people in the US as well, because we're based in Toronto, to go in and build 3D real estate tours of their job site every week so that students can actually walk through that job and see what it's like assembly by assembly by assembly as they build those structures. So those are kind of my 3 personas, but we'll dive into what we do. So GBC has 2 programs that really allow us to think about supporting competitions like this. We have a 2-year renovation technician program. It's sort of half shop-based carpentry training, and then the theory-based, project management, construction math, all those good things. We have a 3-year function too, which really is where I spend most of my time. And we think a lot about teaching applied building science, actually some quite complicated building science calculations. Students learn how to design their own assemblies. And we also focus the big thing too, and we see this in the competition, is you might know how to build something, but we want to make sure that you're able to communicate your ideas. So we do teach Revit, we are moving into teaching SketchUp and teach design principles so that a builder who's going to champion durability can support their ideas and communicate with their team, with their partners. And then we need to make sure they know how to make the money works. So yes, you want to build a passive home. Yes, you want to achieve net zero. Can you make the money work is a really critical step for students to understand. So that's kind of what we do at the college and what I spent so much time and having fun with the last 3 years. And it's been a great place to spend my time. So the program, we teach carpentry techniques. It's in a wood shop. We break down principles, teach all those hands-on skills. which is really great for every student. So many students right now, and we see this a bit in the submissions today. You think about a trade school, majority of our students coming into first year are 17, 18 years old. They have not come from a technical high school because there's not many of those left. So our schools are teaching really rudimentary skills at an early stage because there's such a massive need for training. So we do a lot of the early training before we can get into things like this, which is an applied building science course in the second year. So you're learning how to frame walls, you're learning how to frame roofs and cut hips and all the things Mark used to do as a framer. And we used to just tack on some kind of house wrap, right? And give it an ambiguous name and not know what it's for. So it's really important at an early level, even when we're teaching first year framing, we're talking about control layers. And if you have details where you're wrapping headers for continuity, we're teaching that. We're not just saying stud layout, crown, layout in 16s, and fire it together, right? How to use a rafter square. The big thing I think I want to impart on everyone is how important it is to put building science into each course. So it isn't this elective that Sean said you don't go to. It's in every single course. So if you take framing, you're learning the building science of the framed envelope. If you're taking mechanical design, you're learning how to tape penetrations and think about balancing your systems. I think all that's really important and something we're not perfect. We're trying to get it into all courses so it is woven through the whole fabric, We also then have sort of in the third year, where students get a bit more information, they can start to design their own assemblies. And I think what we're trying to teach students is not to be a designer to compete with people to say, my ideas are better. But it is when you write a set of drawings that they feel competent that they can go, let me just work through the issues and see that I understand what is being drawn and I can execute this. So how to take drawings. So we solicit drawings from architects in the community, and we build one-to-one mock-ups of their details, of the assemblies and of the connections. And then we troubleshoot those to see if we can improve the durability and build those mock-ups to learn. Again, it's one thing to learn building science, but can you communicate your ideas to someone in a clear and articulate manner? I think that's what we really want to teach hands-on students who get it. They get how hard it is to put these things together. How do you put on 9 layers of Gutex or rigid board on the outside? It's a big conundrum. So building that mock-up, feeling confident for us is a big learning goal. And then the other one is when you have ideas, we want to make sure our students, and I think every hands-on trade student should be able to draw at whatever level you can. And this goes back to, it's not design for me, it's communication. Can you take, like drawing on the right, this is done by a second year student, no drawing background, but can they look at a 2-story assembly and understand and show someone where the critical areas are where walls and floors connect? So that simple skill for me to have students be able to do confidently is really important. And if we can get them to a place where they can start to actually break down the assembly of a house by building a quick SketchUp model to see how the layers connect, understand how all the flashing details work. A 2D drawing is very, very flat sometimes, and they need to know how you assemble it. So there's a lot of things trade schools are moving to teach and trying to put building science into each course. And then again, making sure our students, once they're informed and aware, are confident enough to communicate their ideas to other people in a concise manner. The other thing we try and do is really mix, not just students, not just dudes like me, is industry professionals and architects. So we do host workshops where we bring in, industry leading manufacturers and trade trainers. This is a workshop we did last year with SIGA. The group on the far left there, it's 3 people. Those are 3 architects, and they're working with 1 student who wanted to learn how you install certain flashing. The group in the middle at the top, that's a carpenter, works for a builder. There's a building science detailer, and there's a lead of an architectural firm in the red shirt. The group on the right is 3 students and a project manager of a commercial firm. So mixing those kind of learners in these kinds of environments for us is a fun way to think about teaching and getting hands-on and sort of building that physical, understanding of materials. But we all know what happened last March. We weren't doing this anymore. The shops were empty. College closed March 17th, 2020. we didn't open for the whole summer, and we just opened last fall, but for 10% in-person shop classes, for only shop, but everything else is online. And realistically, we'll be online for theory until 2022. So that's really hard for us. So at the same time this thing was happening, let's come full circle to the wall assembly and what Travis and those at BSMB or KC came up with is some beautiful people at the end of February, right when things are starting to get weird, they launched this amazing competition to put a competitive spirit against wall assembly and building science. So Travis and the group at KSMB, KC came up with Kansas City, came up with the wall assembly Sweet 16, which is like a March Madness for wall assemblies. They pitted 16 wall assemblies against each other and have a great discussion. So let's talk just briefly about the inception and how we've kind of riffed on this to make it for students. And Travis can chirp me in the chat. So chirp me if I get this wrong, Travis. So initially created as a way to really just get competition and discussion around building science. So the group solicited entries from 16 professionals across the US, I think a couple from Canada, and really a lot of, it was like a no rules cage match. It was any assembly, any budget, any detail, built, not built, and just a way to get a discussion going. All the entries were kind of pitted against each other in matchups. They were voted for through Instagram chats, pretty labor intensive for Travis and the group to count. And then the top entries are put into a final event that was discussed by top leading experts like Ben Bogie and Christine Williamson in building science to talk about what that looked like. And it's really, really exciting stuff. So when I saw this come up, it's like, holy crap, they're doing it. This is what we need students to get excited about and know that they can enter. And if you remember what architecture school was like for you, if you don't have fully rendered drawings or you don't have built examples, you feel like you can't compete. So this stuck out to me as a nugget that we could think about changing. So why a student competition? So let me show you what I look like and what reminds you how you probably felt last year. This is me like midsummer. This is mid-pandemic, just as this is ending. It's as much as hard on me. This is hard on students, man. I like a tight fade. That hadn't happened in months, and it's feeling rough. So needing something to look forward to was really important to us. So what we did is we reached out to Travis. This is the initial feed, just pulled out of my IG account. I like to give props where props are due every year. So we write people and say, listen, I call it like my jealousy list. What am I jealous of? Contact that person, tell them how great it was, and can I help you when you do it again? It's selfish, right? Reach out to Travis and said, hey, what you did last year was amazing. I want the students to enter it again. Is the due date again in March? So I can get it in my courses and make sure we can produce entries. And it sounds like it's a lot of work to do. So Travis and I riffed quickly on how to come up with a competition for students that supported student work, full stop. Travis and the group at BSMB or KC were on board instantly. And let's talk about what we came up with. So 2021 is when we launched the second annual. This is the Sweet 16 Student Edition. And really what we came up with, Travis and I kind of worked, at nights and evenings and through calls. And it was lovely to work with people that were so passionate about student learning that aren't in education, is if we did this for students, it needed to support all levels of students. So colleges, high schools, universities, those are all different levels of learners, right? And then we wanted to allow not just trade students, but architectural and design students to see what each person could communicate, what their ideas are. The submissions had to support all climate zones and be free to enter. So pretty steep ask, but it is something we wanted to do. And we wanted a type rubric that they can actually work to. So through some workshopping, what we came up with was 6 categories to give ultimate flexibility in what you did, but give you some way to measure what you came up with. So we wanted to make sure we measure performance. We want to make sure we measure buildability. So yes, you built this spaceship made of VIPs, but can you actually assemble it? Do you need a crane? What's that look like? Can you get the material at your job site? Durability. It's a big thing. We thought trade schools could really champion this piece of it. How durable the assembly is you're looking at constructing. Embodied carbon for us is a really interesting topic to think about. Hard thing to measure, as we learned in the competition, but a good thing to think about. You know, what does a high embodied carbon assembly look like against one that could be lower, and just have a discussion, just so we're aware and start to think about it. Cost, obviously, something we have to think about. So, what does your assembly cost to build in your own labor market with materials that you can access? So, I mean, in Ontario, we can access white cedar shingles pretty easily with our local sawmills. That's relatively affordable as a cladding system. Maybe down in Texas, you're importing those, that's expensive for you. So cost, again, is relative. And then we think about LCA as renovators and people who actually build and take them apart. What does it look like to renovate a structure that's full of wool, foam, dense pack, 9 layers of Gutex? What does that look like to take apart? At the end of its life, can you reasonably reuse these things? So that's kind of the matrix we had. We launched wallassembly.com. We secured the domain, launched competition quickly within a few weeks back in March. Got amazing support really early on. Travis was able to pull in, find home building. They hosted all of our live discussions and events, really helped us get the message out there. And from there, really through our networks, we were able to line up an amazing group of judges. So Mike Gurton, Christine Williamson, Matt Bloomquist, who's here, Steve Basic, Ben Bogey, Jake Bruton, and Emily Mottram. So amazing group. It's what I would dream about as a student, to have people critique my work. And that was fantastic. And then we had no idea sponsors would come. But when people hear about supporting students, everyone on this list, we did not have to solicit. We didn't have to ask. They all heard about it and offered. And it just became a bit more give energy to what we're up to. So Rockwell came on board, Fine Home Building, Emu Building Systems, Siga, Huber Wood, Intelligent Memories out of the UK, MT Copeland, which is now just called Copeland, T-Stud, of course, and the Endeavor Center, and the Beam tool, which is a carbon accounting tool. So this is fantastic for us. We figured, okay, we've nailed this, right? We're on Fine Home Building. We've got great judges. We've got great sponsors. But let me tell you, it is hard to connect with students. So this is what it looked like. So this is pull off our website. This is how many people were looking at that site in the competition period. So 1,000 people looked at it, or maybe 1,200 people. How many people do you think actually entered? Students. Help you out. 9, which is great, right? Really great. Some people think, oh man, that's like your sweet 16. How do you do that? But we'll get to this in the learning. The learning is, even when we are as connected as we are, we're all here learning tonight, it is hard to connect to that 18 or 19-year-old who is in a building science class to help champion their ideas. So I have an ask at the end to help us connect with more people, because with all the might and power in the world and popular people on IG and platforms, support from companies, we need to connect with students. And students right now don't listen to me or to you. So we'll talk about that. So what we came up with is we placed the top 8 submissions into a bracket. We grouped all the entries into the same relative climate zone. So at least it's climate zone against climate zone, you know, so a 5A and a 4A, and then a 3A and a 2A would compete head to head. The top 4 entries, based on judges' feedback, moved on to the semifinals. The semifinals, we were really gracious to get support by Emu Systems, did full performance modeling and thermal bridge analysis on the assemblies. And then the carbon analysis was estimated by Builders for Climate Action using the Beam tool. So that really gave the judges and the audience a lot of information on how to evaluate those assemblies, so it wasn't just so token. And then audience feedback was also able to vote. And we got some great matchups. So right now, we'll actually just dive into what the brackets look like, and we'll come back and talk about the summary. So let me just share my other screen. So if you're unfamiliar, this is wallassembly.com. And when you're here, you can still see all of the live competition and all of the live feedback that was created by the judges and see the student work. So what we did to make this all work is we built this is a design thinking tool called Miro. So it's like a graphic mood board. And if you zoom out, you can see the competition in like one slice. So here's the quarterfinals. These are all of the 8 entries by the student groups. Those are whittled down to one winner out of each bracket to create the semifinals. Then we had a final event. So because there's so much to cover here, we'll talk about the kind of the high level of each submission and generally how they scored. So make sure we can get to the end and listen to our students. So what we've done is we kind of took to make the voting, really quite playful. Is if you go in later and look at this, each criteria we had a 1 to 10 rubric, and all of the judges we turned their faces into buttons, so you can see how the 7 judges or 7 heroes voted on your work, and compare that to submission, and see how they thought about your control layers, your durability, and also understand people like Ben Bogey, who's a builder, is he looking more critically at durability? Is someone like Christina Williamson, who is a building science expert, more concerned about performance or durability? Those are interesting things to look at for how their judges are voting. So we thought that was quite fun, and all this was done up front. The judges then also had the ability to provide detailed and descriptive feedback. So each judge received a sticky, and then under each submission, they were able to write feedback. So this is actually Dylan's, who is here tonight. So to get feedback from people like Christine Williamson in such detail is just incredible. So this is all part of that first round. So let's kind of look at the sort of general matchups. Okay. So the first round is we had 2 retrofits submitted, one from New York and one from Toronto. The New York retrofit is of a 3-story multi-family dwelling or multi-family building, is in climate zone 4A. And even though Toronto is a bit further north, we're only in 5A. So it felt like a good matchup to put those 2 against each other. The submittal from Toronto is done by a student who is in a continuing education program at a local university. And the top submission is done by 2 high school students in New York. So really incredible to see the ideas you have coming out of this. And the detail in New York for the assembly is to to take that existing masonry building and basically laminate on the outside. So outsulate on the outside and build that assembly. So what they've got is really adding Gutex. And there's a really healthy debate. If you want to see debate about Gutex as a WB, go look at the live recordings of the competition. So really interesting here as sort of an outsulation installation. And then for Toronto, a lot different. This is a renovation of actually this student's home. And they looked at renovating the interior, which is more conventional, using more conventional assemblies with rigid foam and spray foam in the headers and up in that up the end of that truss. And this really solicited great feedback from builders, architect about details of using a raised heel. These things that we might know as being common, but to someone who's 19, 20, these are kind of new concepts. So the next matchup we had was 2 wall assemblies out of climate zone 5A and 4A. The top submission is done by an architectural student, and the bottom submission that actually won is done by a high school student who's in an applied trades course and builds a real house with his teacher. Like, you can't make this stuff up. It's crazy. And really interesting submissions. You've got, again, a raised steel truss. You're seeing a T-stud on the outside of the wall with zip R on the exterior. They've got an ICF foundation. And this really kind of brought up a lot of good discussions of brown embodied carbon and thinking about what that means. And, should we listen to it, right? Different assembly up top. Again, this is a T-stud wall. It's built as a Larson truss. It's insulated with Haven Lock wool. Has a raised steel truss, nice detail. And then they're actually, in this instance, they're insulating on top of the concrete floor. So it's gravel, 4-inch slab, and then they're insulating on top of that with a thermal break at that foundation wall. So these are really just fun ideas to see what students can come up with. And you see all different levels of rendering ability against different disciplines and schools' abilities. Out of Toronto, we got two 5A assemblies. One is the Golden Wall, which we'll just jump to down here. And this is a really fun assembly that got a lot of interest and was torn into by judges. It's a CLT assembly. So they have a CLT floor system, CLT wall system, and CLT roof system. That then is outslated with Gutex on the exterior walls, and then the roof has basically like a Larson truss style blown in with cellulose. And they're insulating under the slab with Glavel insulated drainage layer. Up top, we've got another assembly here. This is out of Toronto as well. They're using a T-stud on the exterior walls. They've got a service cavity on the interior. They then fill the service cavity with hemp insulation. And then the actual thermal assembly on the exterior, that's the T-stud filled with dense pack. And then they add a continuous insulation layer on the exterior with a wood fiber board. And their under slab is 12 inches of Glavel with, I think this is, so I forget my control layer here. It's the 15 mil Steger wrap, wrapped down into a cellulose-based wood block foundation. So really, really fun stuff. The last two submissions are out of warmer climates than us. So climate zone 3C on the West Coast and 4C. We had the Contrarian, which is, I believe Brian's here with us tonight, is a nice, coming from the colder climates, it's a lighter approach to how they were dealing with this. So they actually dealt with their Dever as painted plywood as the big differentiator between its rivals, with a standard insulated assembly for its wall. And then down here, Climate Zone 4C. This is out of a university, an architectural university in the West Coast. A 2x6 exterior wall, Larson truss, filled with wool, and then tied into an ICF foundation at the rear, and then a non-raised truss and non-insulated roof assembly. So really nice detail. So what the judges did is they voted on each category. We were able to score and then choose winners. And that allowed us in the live final to have the students present their ideas. We learn about the modeling. The judges then voted on really what their pick was. And we, the audience members, also get votes, and we counted their votes as well to figure out who won. So in the final event, we had a retrofit out of Climate Zone 4A in New York against a really smart assembly, the Contrarian in Climate Zone 3C, Southwest Coast. And it was a battle to the end. And really what came out was a lot of interest in high school students pursuing a retrofit, which is harder to do than building a new assembly, and thinking what that means to look at old building stock. So I think the winners are here with us tonight, Dylan and his partner, which is exciting. Like for me, this is what it's all about. Is we made a competition internationally for students, and 2 high school students beat out trade school students with formal building science education, hands-on, architectural students from various universities who had help from various people. And it shows you how exciting and how early we can start with students and learners to teach building science, even at a high school level. So I think that's really important to think about. So we'll dive into that in a second. I'm just going to wrap up here and just talk about, we'll get into the assemblies with the students, is what we kind of learned from this. So the one thing we learned, and I say this as someone who teaches in a school, who feels like he is connected in some way to the community, is connecting with students is tough. Like with an individual student, even with star-studded judges and supporters and having great promotion, is connecting with that person who's 17, 18, 19, 20, who's not following, who's not reading Fun-Holding, who's not looking at all of your amazing publications and your companies. How do we connect with that student? Because that's how we support their learning. Number 2 is what we learned is we really don't, as a group and as a community, have a list of all the schools teaching building science in North America. And that, I think, is something we need to come to together and think about who teaches building science in any degree. Hands-on school, interior design school, talking about solar gain. Who are those schools? So we can start to share information with them, support those teachers. And when we have competitions like this, make sure we are soliciting a larger audience would be really helpful. The other thing we learned is to get schools on board and to support students is we need to not launch this in the winter. We have to launch this in the summer before, so that those teachers who come in on a contract can actually institute that as one of their shop or their course projects. We can support them through documentation or resources, and they can hopefully have students have some comfort submitting something in March the following year. So that's really what stood out to us, as takeaways, because I think there's so much here for us to help promote, and really it comes to us as a group figuring out how we connect with those younger people that are in our communities and need help. So I want to wrap up with two things I want help with, and I think that you can action is if you know of a school who teaches any kind of building science or hands-on trades, I need you to email sweet16@wallassembly.com and just let us know about them. So when we launch the new competition, we can make sure to reach out to those people and let them know it exists and help support them in whatever way that we can. And from where we can do for you is when we build that list of a comprehensive list of trade schools and our school is teaching these things, maybe you want to talk to their graduates, you want to help out, we'll share that list with this community. The second thing I want to ask you for, this is a personal favor. I'm someone who only joined my school 3 years ago to teach. I worked in the community for 15 years and I didn't know my program taught this program. And it meant that teacher teaching at that time didn't know how to find me either. So it's broken telephone. Is to support schools is many teachers are isolated. They're teaching a course, and it's much easier if you are passionate about teaching, you want to help that class just learn from your best principles, see your projects, you build cool stuff, you've got great resources you want to share. It's easier for you to find them and say, hey, can I chat with you? Can I be a guest speaker? Do you need any help with this? Do you need example projects? Then them finding you. It's almost impossible. So they're at least the bigger thing to find, and finding them, just reaching out, IG, email, call them. It really helps when someone offers out to someone who, like myself, and teachers to say, hey, I've got this great project. It's a retrofit downtown. You're going for passive level certification. Would you be interested in having the students virtually tour it? Heck yes, is my answer. And that is easier for them than me trying to find them. So two things, please think about trade schools or building schools, you know that he's building science, and let me know about it through, and Travis and I, through sweet16@wallassembly.com. And two, think about a school that you can reach out to and say, hey, I'm good at this. I'm interested about this. Does that align with what your needs are? That is what we need right now to help push this. So we get it in high schools, we get it in trade schools, we get it in colleges, and we get it in universities.
Wow. It's pretty amazing. I think everyone should unmute and give Connor a big upperoonie.
Here, here.
Well done.
Mr. Inspiration of the evening.
Connor, fantastic. That is a lot of work, not only by you, but by the students. How long did this process take from start to finish? I just have to know.
Yeah, so Travis and I, who's here tonight, we had our initial discussion on New Year's Eve of 2021.
We're such dorks.
At what time?
There he is. There he is. Yeah, I recognize him. Like, my wife allowed me to chat with a stranger on New Year's? This is great. And he replied. I'm like, I found my people. It was great. So we chatted initially on New Year's Eve of 2021, so December 31st. And the competition was live and launched by March 14th. So
Some fast footwork.
Yeah, so two months and change. And the students had 2 weeks 2.5 weeks to create their entries, which are substantial thinking and work to then submit to us. And then the first round of judging, we gave the judges a week and a half to actually review the submissions, make comments, and our live show was the following week. So the whole thing from inception to finish was done in 3.5 months.
More applause.
Connor does deserve the applause, because literally all the stuff where he was like, and then we did this, and then we did this. Connor built that whole website. Connor did the entire rubric. He figured out how to do that whole Miro board. I don't know how to do any of that. I talked to sponsors. I talked to some people on Instagram, but Connor, it's appropriate that he gave the presentation, because this year's student competition really is his labor, more so than KCBS and Beer. So you have my sincere gratitude and applause for both the presentation tonight and the fantastic thing that you built for the students this year.
Oh man, it's just fun to do. Thank you.
Yeah,
it's just fun to do. I think what
And
you
between
find
the
is
two of you, you're the dynamic duo. And I think this is a perfect example of what happens when you take students away from teachers. They find a way to get to them.
100%. I think it shows me too, like how powerful and connected the building industry is on social media platforms. I never really used it very much a year and a half ago, 2 years ago. The fact that I could, Travis created a competition that launched on a social media platform, launched on Instagram. We connected through that platform. How easy it is to find your mentors or people you look up to and ask questions to and network. Travis and I have never met in person, and based on the border, might not ever happen. But it shows you how you can reach out to someone and collaborate just by, asking the question. Like, I do believe the answer, if you never ask a question, theirs is always no. Travis, you create a great competition. Can we do it together? Can we co-opt it for students only and launch it next year? I didn't know the answer would be yes, but I think asking the question is always important.
Well, and you breathed life into it, because the competition in its first year, it was a lot of heavy hitters. It was a who's who of people we look up to in building science, the Mike Mains and the Jake Brutons and the Steve Basics, and those guys have a ton of influence. So it was a competition, but it was mostly a popularity competition on Instagram. So we didn't test the assemblies. We didn't take all the data that you provided from Enrico at EMU on this. We didn't have that in the first year. So it was very much just a popularity contest and kind of a fun aside. So this year, it was a real competition. Like there was data collected. There was a comparison of the carbon debt. There was all of the things that were lacking in the first year. We threw on the students, which may or may not be fair, but I think it's more productive for the industry at large to be able to make those comparisons. We talked about some of the things that maybe we could have done better, some of the things that we felt like skewed the competition in a certain direction, that maybe we would make a different decision next year, or maybe we have multiple different competitions. There was talk about doing a completely, you can only enter this with an actual built assembly that you sold to a client. It's like, well, that's a super fun project. I wonder how many entrants we'll get in that one. Yeah. There's a lot of different ways to take this, but the beauty of it is the kind of the level of enthusiasm that you brought to something that I was like, I don't know if I want to mess with this year. And then you turned it into something that I think made a world more good, just, involving students in anything, but moving the industry forward with actionable information is so much more valuable than this guy gets my vote because I like him better. Well, that's not really helping as much in my view.
I'd like to first and foremost, thank you for being on, Travis. Without year one and without what happened with BSKC and the partners you have, there would never have been a year two. So that foundation allows the house to build. The other interesting remark I want to add is I found out something tonight when Connor relayed that there was roughly 1,000 of views to the wall assembly domain. I'm particularly excited that the 10 to what grew to, I guess, 16 applicants, those folks that took action, the students that took action. So 1,000 saw it. Great, this is pretty candy. I like shiny objects, love it. But the folks that took action committed themselves and then brought this into reality is remarkable. And we'll hear in the second hour tonight some of those stories of people that learned how to draw. They never had SketchUp before. They learned how for the competition, and they reached out to manufacturers and suppliers and said, we're trying to build a wall assembly. We don't know what to use. And they learned through the process. That commitment, that action is unfounded and deserves high praise. Regardless of what you do in the rest of your life, that deserves high praise. And I'm overwhelmed with what those folks did to do it. Bless your hearts.
I was going to type
I-
this, but I only type so fast. So I'll just take a second to say it. After Mark and Sean have both thanked me for being on, I feel very uncomfortable here because you guys are all on a level that I'm not up to yet. The Passive House Accelerator group, you guys show a commitment to a level of knowledge and understanding that I'm aspiring to. So I feel very out of place here. So I'm very humbled that you guys would thank me for joining you. I thank you all, the whole group, for the effort that you put into this every week. I've only been able to tune in a few times because of the timing of things, but I will say that the passion that you guys bring to this is not at all unlike the students that join the competition that are really just trying to make things better. So the thanks is to you guys. Excellent, excellent work every week. Thank you.
Hey, Travis, you know that you're a brother and you're part of the family with a PH, brother. It's all of us. That's why it's an inclusive and shared group. And whatchamacallit, Connor remarked that we all met through social media, and it is fun. I get constantly confused between Connor and Matt Bloomquist with your guys's Instagram handles and whatnot. So we're getting close to the end of the first hour. So in respect to that, we have a tradition, and that's when the presenter has a moment to acknowledge and talk about a mentor in their life. So Connor, mic goes back to you, and then off to Zach.
Beautiful. Thanks, Mark. You know, when I think about it, I've got a lot of mentors that have helped me get to where I am, but the person who stands out the most is really my dad. So let me just share it here. Here he is. So I was lucky. I grew up in a building business. My dad's been running his own design, build, and renovation firm for 42 years. Started in 1979. So I had the fortune of being pulled out of school in high school when they're taking a roof off to learn how a roof comes off. Get pulled out of tech school, pulled out of trade school, out of math class when they're setting a beam in a house to see how that works. Summers are building. And then later, so the trade stuff, people will teach you, right? We understand that part. But he was actually take me to the business, teach me the business side of how the money works and allow me to make decisions. The amount of money my learning was expensive. Let me tell you this. In 2 houses, I ripped out the wrong room because the scope of work was poorly written. Well, it's my mistake. I didn't confirm. I ripped out the wrong room. That's $15,000 worth of stuff. But he believed in me to make those decisions and say, look, you're going to run your own jobs. You need to understand how to communicate, how to take responsibility for it, and you need to talk to those clients and make amends and talk it through. Later, through building science, you know, they're not a building science focused company. They're learning how to do it because it's not comfortable, right? But they were able to pursue and certify for their first lead home, for London's first lead for homes project, because it was a passion of mine to learn about. So he's really taught me a lot about how to work hard, work smart, not hard, and teach me the basic business principles of how to support a team, grow a business, and support the people around you for do the thing they're best at. So, and this is what he does. He's got a background in economics, runs a big company, but what's he want to do? He wants to cut a set of stringers with a saw because he can. And I think it's impressive to know that even at whatever level of success you have, you know, be humble and work with your team, teach them really basic skills and teach them big stuff too. But try and work to all levels and, you know, engage with the people around you, but what they want to learn about and work with them. So yeah, That's him. That's my mentor.
Thank you, Connor. We're gonna leave it on that note and hand it over to Zach to thank the sponsors. But now we know where you got the show me to teach me from. Thank you so much. What a
thank
great
you.
mentor.
Yeah, very inspiring, Connor. Thank you. So everything that we do with the Passive House Accelerator comes thanks to support from our sponsors. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingwe Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy and Research Development Authority. Thank you also to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Inotech Windows and Doors, and US Engineered Wood T-Stud.